Understanding ratios. A ratio is the quantitative relationship between two amounts showing the number of times one value contains or is contained within the other. That means comparing how two amounts relate to each other using division. Ratios are used to compare a part to a whole. Let's look at a few examples. The ratio of computers to students in the class is 1 to 3. This would mean that for every one computer in a classroom, there are 3 students that would need to share the computer. Here, the ratio of computers to students in the class is 1 to 1. This would mean that for every one computer in a classroom, there is 1 student to use the computer. Now, let's take a look at a few examples in context. In Alaska, students only have about 5 snow days out of 180 days of school. What is the ratio of days students miss school to the total number of school days? To solve for this, we would need to first write the ratio as a fraction. We already know that every fraction is a division problem, which goes to show how we are relating the two numbers using division. Writing numbers as ratios and fractions are interchangeable. Both of these means 5 to 180. To understand this ratio, we need to simplify the fraction. 5 180ths. Because these numbers end with 5 and 0, they are both divisible by 5. So I'm going to divide 5 by 5 and 180 by 5, which is going to give me 1 over 36. So I can write this 1 to 36 as a ratio, which is the same as 1 to 36. So 1 out of 36 school days are snow days. Let's take a look at our next example. Out of every 100 M&Ms, how many are green? Estimated number of green M&Ms in a party-sized bag is 200. The approximate number of M&Ms in a party-sized bag, 2,000. First, we write this as a fraction, 200 over 2,000. Now we pick a number that we can divide evenly into the numerator and denominator. I could pick 100 to divide both, but when I divide 2,000 by 100, we get 20. And my question wants to know how many out of 100, so this number won't work. I'm going to start by dividing both numbers by 10. This gives me 20 over 200. Now I need to divide both numbers by 2 so that my denominator ends up as 100. 10 out of every 100 M&Ms are green. Now let's try applying what we've learned using historical data. Out of every 1,000 Americans in the early 1870s, how many were cowboys? Estimated number of cowboys in early 1870s was 40,000. The approximate U.S. population in the early 1870s, 40 million. The ratio of cowboys to the population is 40,000 to 40 million. Written as a ratio, it looks like this, 40,000 to 40 million. First, we need to change these numbers into a fraction. Now we need to simplify, keeping in mind that we want the denominator to end as 1,000. Normally, when simplifying, you find the greatest common factor and divide both the numerator and denominator by that number. But these numbers are so large that I'm going to pick a number and get started. I'm going to start by dividing by 1,000. 40,000 divided by 1,000 is 40. And 40 million divided by 1,000 is 40,000. Now my denominator is still not 1,000, so I'm not finished. I'm going to divide both of these by 10. And 40 divided by 10 is 4. And 40,000 divided by 10 is 4,000. Now I'm going to divide both numbers by 4. 4 divided by 4 is 1. And 4,000 divided by 4 is 1,000. So, 1 out of every 1,000 people in the early 1870s were cowboys. After watching this video, I hope you have a better understanding of ratios. Have fun working with ratios.